Today in the workshop, we're working with the MyoWare Muscle Sensor Kit. We'll see how EMGs work and how we can use the MyoWare sensor to perform our own EMG experiments. We'll also attempt to use two MyoWare sensors to control a robot arm. We're putting some muscle into it today, so welcome to the workshop. Well, hello and welcome to the workshop, and today we're going to be working with something slightly different than anything we've done before, and that is we are going to be working with a MyoWare EMG sensor kit. Now, you may have had an EMG at some point, either in a hospital or in a clinic, and as you'll recall, they attached a number of electrodes to your body, and then they ran it through a special machine which produced a long chart that had a graph on it and a bunch of numbers, and I'm sure, like myself, you didn't understand a thing about it, but to a medical professional this can be invaluable information. Now, I want to stress today we are not building a medical quality device, and we are certainly not doing any medical experiments. This is all just for fun, and you can find a few practical uses for this. You could use it as a gesture sensor, you could use it to control a video game, or as you'll see later in this video, you could even use it to control a robot arm. So before we begin, let's learn a little bit about EMG sensors and the MyoWare sensor. Electromyography is the science of sensing electrical activity that is produced by skeletal muscles. An electromyograph is an instrument that performs an electromyography, and an electromyogram is a record of an electromyography. Collectively, these are referred to as an EMG. Motor neurons are located in your brain and your spinal cord. When you want to move a muscle, the motor neurons transmit electrical signals down to that muscle. These signals can cause the muscles to contract. An electromyograph can measure these signals. In practice, electrodes are placed along a neuron path. Some electrodes are also placed on different paths in order to get a reference signal. The electromyograph can measure the speed and the strength of these signals. EMGs are used in medical diagnostics. They're also used in scientific research. EMGs can be used for muscle training, and they can even be used in gesture sensing applications. Today we will be working with the inexpensive MyoWare Muscle Sensor. This is a small wearable design. It operates on 2.9 to 5.7 volts DC. The MyoWare Muscle Sensor can output both an EMG envelope and raw EMG signals. The device also features an adjustable gain control to calibrate it for your own body. The MyoWare Muscle Sensor has a number of electrodes which need to be snapped onto disposable pads to contact your skin. One of the electrodes is a reference muscle electrode. This is placed along a spot in your body that does not contain the muscular activity that you're trying to measure. There are also two electrodes that are used to measure the muscle activity, the end electrode and the middle muscle electrode. On the other side of the MyoWare sensor, we can see the connection for the power supply voltage, the power supply ground, and the output signal. There are also connections for the electrodes, for the middle muscle, the end muscle, and the reference muscle. There are also pinouts for the raw EMG signal. For shield power, this is power that can be supplied to shields that can be attached to the MyoWare Muscle Sensor. And there's also a ground connection here. The sensor also has an on-off switch and a small potentiometer that is used as a gain control. The MyoWare Muscle Sensor features a number of accessory shields that can be added to improve its versatility and functionality. So let's go and take a look at the MyoWare muscle sensors now. So here's the contents of the MyoWare kit from Sparkfun, and as you can see, it consists of a number of small boards, including the MyoWare sensor itself and a number of shield boards that I'll cover in a moment. There also are some accessories included. This is an extender cable that you can use to connect sensors pretty well anywhere in your body without actually having to have the MyoWare sensor device pressed up against your body. Here are a number of the contact pads that you can use, and these are pretty standard items, and you can replace these if you wish, and you can use them a couple of times before you need to replace them. And these are just a number of connectors for the shield that you'll need to solder in order to use all these different shields. So let's take a look at these individual boards. Now this one over here, of course, is the MyoWare sensor itself, and if we flip it over, we can see we've got some contact areas in order to put those pads. There's also a third wire over here in order to put the pads. So you use 3 pads whenever you're using one of these sensors. And this is pretty well complete in itself as it stands, but you can also add extra shields onto it. Now this is an interesting shield over here. This is an LED shield, and this is an LED bar graph over here that you can use with the MyoWare sensor. And on the back of it, it has a battery. So this is a self-powered one as well. And it's also got a connector over here for a micro USB. And so you can attach this to the MyoWare sensor and pretty well self-power everything. Now this is a power shield, and as you can see, it just simply consists of a place to put 2 coin cell batteries, and that's basically it. But you can use this to power the MyoWare device completely on batteries, and you can also, if you wish, stack shields. Now, this is what they call the cable shield, and it just has a connector on it, and that connector is, of course, for this external cable. And this is another shield that is attached to the MyoWare device. And finally, this one here is just a proto shield, and so if you have your own circuitry that you want to wire up, you can put it onto here, and they've got a few of the pins labeled and everything for you there. And again, you would just solder these connectors to it and use it with the main MyoWare shield. So that's the contents of the Sparkfun kit. Now here are the same MyoWare shields, this time with a number of connectors that I've soldered onto them in order that they can actually act like shields. And each one of the boards has sort of a unique requirement for connectors. We can start off over here with the MyoWare board itself, the sensor board. And as you can see, I've got 3 of the connectors soldered onto it over here, with the female side going up. Now the male side, which normally extends on the bottom, you need to trim that on this board, and that is of course because we've got the actual pad connections over here, so you certainly don't want the leads from the connectors digging into your skin. So after you solder it, you're going to need to trim them. Now we'll take a look at the LED shield board, and on this board all you need to do is solder a couple of male connectors on, because you're not going to be stacking anything on top of the LED shield, of course, because you need to be able to see the LEDs. Now when it comes to the board that has the connection for the external probes, the probe board, you can see that I've got pins on it extending downward, and you need to make certain that you've got pins over here on the R, E, and M connections, because these of course are the actual connections for the probe, and the other 2 connectors over here just allow everything to pass through to the next board that you stack on top. This is pretty straightforward. The board that has the 2 coin cells in it that can power the MyoWare unit, you just basically put 2 of the connectors on, and you let the leads go through the bottom over here so that they can connect to a board below it. And finally, on the proto shield over here, you just have 3 of the connectors on it over here. And in this case, the connector over here that contains the RE and M can pass right through so that you can stack the board with the external probes on top of this one so that everything flows through. And otherwise, this is pretty straightforward. So this is what the MyoWare boards look like after you've soldered the connectors onto them. So now that we've seen the components in the MyoWare Muscle Sensor kit, it's time to start putting them to work. And the first thing we're going to use is the LED shield. Now the LED shield is unique in that not only is it a shield, it also supplies power to the MyoWare unit. So we won't need any external power for the next couple of experiments. The shield just snaps on top of the MyoWare unit like a regular shield does, and we can use the pads on the MyoWare to connect it to our skin, and we don't need any external connection whatsoever at this point to an Arduino or any other microcontroller. So let's take out the LED shield and see what we can do with it. So here's the MyoWare Muscle Sensor and the LED shield and 3 of the pads that I'm going to use. So I'm going to start off by putting the pads onto the sensor. This is a better idea than trying to put them on your body first and then attaching them to the sensor, because you can bruise yourself trying to get these things snapped on. So I'll put those 2 onto here and a third one onto the reference pin over here. Now, I'm going to put this shield on top of the board. Now, you have to make absolutely certain that you get it the right way around, because, of course, this is going to carry power down to the board. And so I've got it on top right now, and I can quickly flip the power switch on the board just to make certain everything is working. And as I flip it, you can see the lights light up, and underneath here there's actually an LED. So I'll turn that off right now for a second before I mount it onto myself. Let's pull back these a little bit. We have to take off the protective coatings. And then we need to find a good place to put it. And I'm going to try to put it on my arm over here. I can sort of see that I'm pulling a muscle around over here. So that looks like it might be a good spot for it. Let's just see how that works. So I'm going to actually just stick it onto myself here and then stick the reference pad somewhere where the muscle isn't. So I'm going to try that down over here and we'll see how that works. So I'm going to turn it on. You let it go for a while, and there, as you can see, when I'm moving my hand over here, clenching my fist and activating that muscle, you can see that it does indeed respond to it. And so it looks like it is working, like it is actually picking up my muscle movement and translating the electronic signals and driving the bar graph. So it's a pretty simple way of using the MyoWare Muscle Sensor. So the next MyoWare shield that we're going to look at is the external cable shield, and as its name implies, it is a shield with a 3.5mm jack that will allow you to connect some external electrodes and use the MyoWare sensor in a more conventional fashion. Rather than having the sensor itself attached to your body as a wearable item, you can use these cables and position the sensor somewhere else. Now, one thing you should be aware of, though, is that in an electrically noisy environment, these cables may not work very well, as they are susceptible to external electrical noise. After all, the electric current that it's picking up from your skin is quite small, so anything in the neighborhood could overwhelm it. However, in the proper circumstances, these cables can work just fine. So let's go and give them a test now. Now, before we start the experiment with the external probes, it's a good idea to figure out what the reference probe, what the middle probe, and what the end probe are. And according to the Sparkfun description, that can vary depending upon the batches. So it's a good idea to use a multimeter like I'm about to do to test it. So I've got my multimeter in continuity. I'm going to put it on the black one. I'm pretty sure that's the reference one, so I'll just measure it out to here. And it is indeed the reference. And the blue one here seems to be my middle one. And that means that the red one will be my end one over here. So I've identified the different probes that I've got. Now, one thing I didn't show you the last time, and that's because of my lack of medical expertise, is that you're really supposed to clean your arm before you use it, and you should use isopropyl alcohol. Now, I'm using one of these pads over here, but you can also use just regular isopropyl and just put it onto a cotton ball or a Kleenex or something like that. And so do that and allow it to dry. Another thing is that I'm starting to run out of the pads that they gave me with the MyoWare Sensor Kit. And so I've purchased a few other ones. I want to see if they work. These are 3M pads, and they're very inexpensive. They work out to something like about 17 cents each when you buy 100 of them. So I'm going to try these pads instead of the original ones that I got from the MyoWare kit. Now on these ones, once you pull them off the backing, they're ready to go. So I'm going to snap them onto the 3 different places. That'll be my reference one, my middle one, and we'll get the end one. Okay, get in there, you. All right. Now we have to get this whole assembly together, so I'm going to take the MyoWare sensor. I'm going to make certain it's off to start off with, and I'm going to plug the shield into it. Make sure I get all the wires in there. Okay, so that's plugged in. And then finally, once again, making certain that I've got this going the right way, we'll plug the LED shield in, which of course should supply power. So if everything is working, when I turn it on, we will indeed get the lights and everything telling me that it's powered up. So my sensors are starting to stick together over here. Clearly I was not cut out to be a medical technician, but I'll put the reference one back here, and I'll put my end one over here, my middle one over there. Put this somewhere where you can see it. Start it off. When you start off, it needs to get itself calibrated a bit, and there we go. And if you can see that, it does seem indeed like, again, it is reading my muscles, and I'm using it with the remote probes, which makes it a little bit easier than mounting it on yourself, especially when you're stacking a number of shields that can get a bit unwieldy. And it seems to work quite well with the external probes. So now that we've used the MyoWare sensor on its own, it's time to bring a microcontroller into the picture, and I'm going to connect the MyoWare sensor to an Arduino Uno. Now you could use pretty well any microcontroller for these experiments. The only requirement is that it has an analog to digital converter, and pretty well every microcontroller does. But before we hook everything up, there are some safety considerations that we need to take into account. So let's go and examine these safety considerations first, and then we will hook our MyoWare sensor up to an Arduino Uno. The MyoWare sensor does not send any electricity through its probes. These probes are simply sensor inputs. You can think of them as the input to a very sensitive voltmeter, or even more accurately, as the input to an audio amplifier. The sensor itself operates on very low voltage. The MyoWare device is completely safe when used in standalone mode, as we've used it already. When used with a microcontroller, the MyoWare sensor is connected to its analog input. It can also be powered from the microcontroller, taking either 3.3 or 5 volts from it. You can also hook it up so that the MyoWare sensor is battery powered and does not receive power from the microcontroller. However, even in this case, there still needs to be a common ground connection, and that's where the issue lies. Now, if the microcontroller is a standalone device and is battery powered, there is no problem with ground loops or anything like that. You have no connection to the AC line or the AC ground in this configuration, and it's completely safe. The problem arises, however, when using a desktop computer or any computer that is connected to the AC power line. In this case, there is a possibility, slight as it may be, that a problem in the grounding could be translated back to the MyoWare sensor. One method of avoiding this is simply to use something like a notebook or laptop computer that is not connected to an external monitor and not connected to the AC line. So in this case, if the computer is completely battery powered and isolated from AC, once again the MyoWare sensor will be perfectly safe. But you can use the MyoWare sensor connected to a computer that is connected to the AC line if you use a device called a USB Isolator. Inserted between the computer and the microcontroller, this effectively isolates the ground of the computer from the ground of the microcontroller and rendering the MyoWare sensor system perfectly safe. One popular isolator is the Adafruit 100 milliamp full-speed USB isolator, and this is the one that I'm going to be using in our experiments. So let's go and take a look at this device now. Now here's the Adafruit USB Isolator board, and as you can see it's a fairly simplistic board with a micro USB connector as an input and a standard USB connector as its output. Now the board does have one thing on it, a small little switch that you can see over here, and this is a speed selector switch, and they actually tell you on the back how you can set the speed selector switch. It basically has to do with timing and such, as to whether you're using it with something like a mouse or a keyboard or something. So you can experiment with the position of that switch. We probably don't need the high-speed connection just for the serial monitor that we're doing, but you should just experiment with it just to see what kind of results you get. But otherwise, it is a very simple board, very easy to use, and it will protect you from any possibility of a ground loop forcing itself back to the MyoWare sensor. For our first experiment, we'll require an Arduino Uno and a MyoWare Muscle Sensor. The hookup is very simple. The positive or VCC side of the MyoWare sensor is connected to the 5-volt output from the Arduino Uno. The negative or power ground of the MyoWare sensor is connected to the Arduino's ground, and the signal output from the MyoWare sensor is connected to analog input A0. And this completes the wiring. Now let's go and take a look at some code we can use with our MyoWare sensor. Now here's a sketch that we're going to be using to test the MyoWare Muscle Sensor, and this is probably one of the simplest sketches you've ever seen, because essentially all we are doing is reading the input from the analog port and writing it out to the serial monitor. So we're going to start off by defining what pin we're actually using, and we are using analog pin A0, so it's sensor pin 0. We are going to define an integer to hold the value from that port, and we're going to call that sensor value. And then in the setup, we just set up our serial monitor. I'm setting it up at 9600 baud, and we go into the loop, which is pretty well what you would expect. We are going to do an analog read on that sensor pin and assign the result to sensor value, and just print sensor value out to the serial port. So again, a very simple sketch. Let's load it to the Arduino and hook up the MyoWare sensor to my arm and see what happens. Okay, I'm set up to test everything with the Arduino. I've been using the 3M pads on this, and I had to trim the pads down for the ones that actually attach to the sensor unit because the base of them is just a little bit too big. But that's only a foam section. It's not actually part of where the electrode contacts, so that'll be fine. And as you can see, I've got my Arduino, and I've also got my Adafruit USB Isolator over here. And so I'm all set to go right now. Now I'm going to start off by cleaning off a section of my arm again. That should be fine. And we'll start peeling these things off of the pads. Do that. And here, I left this one as full size. This is the reference one. And we'll just stick this onto my arm over here. Put the reference down somewhere about over here. And I'm going to put the serial monitor on right now, so let's just go and start that. And I'm going to turn on the MyoWare Muscle Sensor. Now we're going to let that stabilize a little bit, because as you recall at the beginning it needs to stabilize. And I'm going to clench my fist, and as you can see we're getting some numbers over here, and they're going by pretty rapidly. They seem to be going higher when I clench my fist, and they seem to be dropping off when I relax my muscle. Now, it's pretty hard to see things, though, using the serial monitor, so a better tool to use would be the serial plotter. So I'm going to open up the plotter and clench my fist and relax. And we are seeing some results, although they're pretty erratic and a little bit difficult to interpret. But the reason for that is if you look at the y-axis of the plotter, when I relax my muscle, the y-axis goes down to a very low value, and when I clench my fist, it goes up to a very high value. So this is working, but it's a little bit difficult to actually see it because of this dynamically changing y-axis. And so I'm going to try to rewrite the sketch in order to freeze that y-axis so that we can get a better reading. So let's go ahead and do that right now. Now, in order to resolve the issue where the y-axis on the serial plotter continues to reconfigure itself, we're going to use a little trick in our code, and it's a pretty simple trick, actually. Now, we'll start off identical to the way we did before, defining the sensor pin, which is the analog input, and we'll define a sensor value that represents the value of the voltage at that input. And then we'll go into our setup and set up the serial port at 9600 like we did before, and we'll go and we'll read that pin and assign it the sensor value. So we've already done identically what we did in the last sketch. But here's where things change. We're going to add a couple of fake plots to the output, and that will stabilize the y-axis. So we're going to add a plot at the value of 0, and this will create a line at the very bottom of our display at the 0 point. And we're going to do the same thing at a value of 1000. And so this will create a solid output at 1000. So our display will always range from 0 to 1000. Now you might wonder why 1000? Why not 1024? Because after all, the analog to digital converter is capable of giving values from 0 to 1023. Well, the reason we didn't do that is because if we use 1024, it won't scale to 1024 at the side. Instead, it'll scale to about 1500 because it goes up in increments. And so I decided that 1000 is fine, and if we happen to go above 1000, it'll just show as clipping. And so after that, we go and print the actual sensor value, which should be in the range between 0 and 1000. And so we'll see our sensor reading in the middle of these two lines, and the y-axis should stay stable. So let's load this up to the Arduino and see if it works out. Okay, so here we are with the new improved sketch, and as you can see, we're now going from a range of 0 to 1000, and we're down near the bottom because I haven't clenched my muscle. So let me clench the muscle, and you can see we're climbing. We fall when I release. I'll clench it again, and we are going up. The more I clench it, and now we're going down when I release it. So this is a much easier display to see because the y-axis is not dynamically changing, and it's a way that we can experiment with the MyoWare Muscle Sensor. Now for our final experiment today, I dragged out something that I used in one of my earliest videos, and it's this. It's the MeArm, and the MeArm is a small robotic arm that is used for educational purposes, and it has 4 servo motors on it. And so what I'm going to do is I'm going to drive the MeArm with an Arduino Uno, and I'm going to connect the MyoWare sensor, or actually 2 MyoWare sensors, to the device, and we're going to see if I can use the power of my own muscles to move the MeArm around. So let's take a closer look at the MeArm, then I'll show you how I hooked it up, and we'll see if I'm going to have any success controlling this thing using the power of my own muscles. Now here's my MeArm robotic arm, for those of you who don't remember it, and I wouldn't blame you, it's been quite a while. It's basically a simple demonstrator arm. It's made of acrylic, and it went together pretty easily. It would have gone together a lot easier had I remembered to pull all the protective paper off of it at the beginning, but that's water under the bridge. At any rate, you can see on the base over here, it's got a servo. That's what's called the middle motor, and then two called left and right. The left motor moves this part of the MyoWare mechanism over here, and the right one moves this part of the mechanism over here. And we can also see on the top we've got a motor, and that's called the claw, and that just basically moves this over here. And so it's a basically simple robotic arm. Now, of course, if you don't have a me arm and you want to repeat these experiments, you could just use any robot arm that uses servo motors. It really doesn't matter what you're using. Or you could even just use a couple of servos and hack something together just for demonstration purposes. So now let's go and see what it would take to control this using my own arm. For our robot arm experiment, we'll require an Arduino Uno, two MyoWare Muscle Sensors, two potentiometers. These need to be linear taper, and any value of 5K or higher will be fine. We'll also require the 4 servo motors that are on the me arm. If you're using another robot arm, you can just pick 4 of the servos on that arm. And we'll require a 6-volt battery to power the servos. Note that it is imperative to use battery power and not an AC power adapter. We'll begin by connecting the 5-volt output of the Arduino to the plus or VCC of the first MyoWare sensor. We'll also connect the same 5 volts to the plus or VCC of the second MyoWare sensor, and we'll connect the 5 volts to one side of both of the potentiometers. The Arduino's ground will be connected to the negative or ground in of the first MyoWare sensor. We'll make the same connection to the second MyoWare sensor, and we'll connect the ground to the other end of both of the potentiometers. The signal output from the first MyoWare sensor will be connected to the Arduino's analog input A0. The output of the second MyoWare sensor will be connected to A1. The wiper of the first potentiometer will be connected to A2, and the wiper of the second pot will be connected to analog input A3. The negative connection from the battery pack will be connected to the ground of all of the servo motors. On most servos, this is either a black or a brown lead. We'll also connect our ground to the Arduino ground. This is a very important connection, so don't omit it. The positive output of the battery pack will be connected to the positive side of all of the servo motors. The control lead from the middle servo will be connected to Arduino digital output 11. The left servo's control lead will be connected to digital output 10. The right servo's control line will be connected to Arduino digital pin 9, and the control line from the claw servo will be connected to Arduino pin 6. And this completes our wiring. Now here's a sketch that we're going to use to attempt to control the me arm with the MyoWare sensors. And note that I use the word attempt. There is a lot of fine-tuning you'll have to do to this sketch in order to get it to work perfectly, but it will give you the basis of something to work on. Now it's actually a pretty simple sketch. It just has a lot of variables in it. Again, it has a lot of variables so that you can fine-tune it. Now we'll start off by including the servo library. This is a built-in library on your Arduino IDE, so you won't need to install anything. Then we define 4 servo objects to represent the 4 servo motors in the me arm. Now if you have additional servo motors in your arm, you can expand upon this accordingly. Next, we'll define a number of integers that represent the servo position. So these integers will vary between 0 and 180 degrees, which is the positions that you can place your servo motor into. Then we define all the inputs, the 2 inputs for the 2 MyoWare sensors and the 2 inputs for the potentiometers. And the reason for the potentiometers is just so we can position the other 2 motors into a position and so that they don't end up in some strange position. Okay, then after that we have a number of integers that we are going to use to represent the values that we get from the potentiometers and from the 2 sensors. Then we have some integers that represent the minimum and maximum values of travel for each of the servo motors, and they're all set to 0 and 180 degrees. However, in your robot arm, you may have a servo or two that you don't want to go the full range, and you can set the range here accordingly. Over here, we have some variables to determine the maximum and minimum values that we are going to get from the MyoWare sensors. And this is where most of the fine tuning is going to occur. Now, you'll notice for sensor 1, I have determined the value to be 25 and 530. However, that is through my own experimentation, and you may not and probably will not use the same values. These values can be anywhere from a low of 0 to a high of 1023. The way that you can get these values is to apply it to our previous experiment with the Arduino and flex your muscle and note from the serial monitor what the minimum value and maximum value you got when you flexed your muscle, and then put those in accordingly. And this will allow you to obtain a better range of control. Then after that, we go into the setup. In the setup, we're setting up a serial monitor, and that's only for diagnostic purposes. You can run this completely independent of the computer, and you won't need the serial monitor. But if you're having trouble, and quite frankly, you probably will need to do some fine-tuning, you can use the serial monitor just to determine a few things and then adjust your sketch accordingly. Then we'll attach the servo motors to the connections that we had, and these just match what you saw in the wiring diagram. And then we add a 5-second delay at the end of the setup, and the reason for that is that the MyoWare sensors need to stabilize. They need to get a baseline signal, and so we give it about 5 seconds to do that, and you can change that delay time if you find it's not enough or if it's too long. Then we go into the loop, and the loop is actually pretty simple. We do basically the same thing for all 4 of the servo motors. For the sensors, we're going to take the value of them by doing an analog read from the sensor pins, and for the potentiometers, we'll get their value by reading the potentiometer pins. And then we'll go and compute the positions for the middle and the left, which are driven by the potentiometers. So we'll use a map command, and we'll take the value that we have received. We'll map it between 0 and 1023, because that's going to be what the value the pot can travel. And we'll do it to the minimum and the maximum value for both the middle and the left servo motor. And so this will allow you to control those 2 motors with the potentiometer. Then we do the same thing for the other servo motors, which are being controlled by the MyoWare sensors. The only difference here is instead of using 0 and 1023, we take that minimum and maximum value that we've computed and apply it to the map function and get the position for the right and the claw servo motors. And then we just write that out to the servo motors. We write their positions to move the servos into the correct position. Here is where we have the serial monitor, and you can add additional things to here if you're troubleshooting, or you can remove some of these if that's too much information. After that, we apply a slight delay. Again, you can adjust this value accordingly. That just prevents the servos from chattering too much, and we go back up and do the loop over again. So it's a relatively simple sketch. As I said, it's going to require a lot of fine-tuning to get it to work, so don't expect it to work on the first or even second try the way that you want. You'll probably have to modify those values. But let's load it up to the Arduino and see if there's any chance that I can actually move my servo arm with my muscles. Alright, well, I've got sensors plastered all over my body right now. Now, it's very difficult trying to figure out which sensor placement to use for the up-down motion on my arm, and so I've used these ones over here and tried this as the reference. Down over here, I've got the MyoWare sensor that should be able to measure my claw or my clenching of my fist, and so I'm just going to plug myself into everything here. I'll put the remote sensor over here, and I've got 3 wires here I've got to join up, so let's just match the colors here. Hopefully that green one will make good contact. It's not making as nice a contact as I want. And the red one. put the power on for the servo motors. And now I've got a 9-volt battery that I'm going to power the Arduino with, so I'm using complete power and I've disconnected myself. I can see that already. I may just need to connect these ones directly. Let's just try it that way. In the meantime, my arm is going nuts. The signal cable, the negative side, and the positive side. Okay, I've got current on there, I've got current on both sensors. Now, let's just see. I am able, it would seem, to do the claw as I move my arm, squeeze my hand. I can do the claw. Now the up-down motion, it is responding to it. Not exactly the way I'd want it to respond to it, but again, I may not even have the sensors in the correct position right now. However, when I do make that movement, you definitely see there's a movement on the servo. So this is kind of an experiment in progress, I would say. The claw's working pretty good. The arm movement, not exactly as well as I'd like it to work, but it is responding to the MyoWare sensor. And so we have a basic setup here right now that we could work with. We could fine-tune some of the variables and, even more importantly, fine-tune the position of these sensors. And I think eventually, working at this long enough, I probably could have some degree of control of my me arm using my own arm thanks to these MyoWare sensors. And so, as you can see, the MyoWare sensor makes something as complex as EMG very simple, and it's fun to play with. I'm sure you could even find a few practical applications for this, aside from controlling a MeArm robotic arm. Now, if you want some more information about the MyoWare sensor, or if you'd like to grab the code that I used today, you'll find all of that in an article that accompanies this video, and that's on the dronebotworkshop.com website. You'll find a link to that article right below the video in the description. And while you're on the website, if you haven't already, please consider signing up for my newsletter. It's not a sales letter, it's just my way of letting you know what is going on here in the workshop, and also of previewing things for you that you will eventually see here on the YouTube channel. And speaking of that YouTube channel, if you haven't subscribed yet, please do. All you need to do is click on the red subscribe button and also click on that bell notification. And assuming that you've enabled notifications on your YouTube, you'll get notified every time I make a new video. And finally, if you'd like to discuss this sensor, or if you'd like to correct many of the medical inaccuracies I'm sure that I've given you today, the best place to do that is on the DroneBot Workshop forum. And again, it is free to join the forum, and you can use the forum to find answers to any problems you might be having with your projects, or just to discuss things with a number of like-minded people. And so please sign up for the forum. It would be nice to chat to you over there. So until we meet the next time, please take good care of yourself, please stay safe, and I will see you again very soon here in the DroneBot Workshop. Goodbye for now. Okay, now the fun part. I gotta get these things off of my arm. Ow. Ow. Ooh, that hurts. Ooh, that isn't so bad. Come on. Come on. Get off of there. Ow, ow. Oh, it's got some hair there. Oh. Now this one. Ow. Oh, these two are going to be tough. Oh. Get off of there. Come on. Ow. Oh, it's got hair. Owie, owie, owie. Oh, God, the things I do for this workshop. Oh.